Hello everybody, and welcome to our project presentation. This is Tal Oyer speaking, and here by my side, my great partner, Tomer Cohen. As part of our computer science studying in the College of Management Academic Studies, we were asked to carry out a Java project. And today, we are so proud and excited to present to you our final Java project. So, let's begin. In our project, we were asked to create a three dimensions maze. First, let's see the two algorithms we used in order to deal with our maze-solving problem. The BFS algorithm. BFS stands for Best First Search. This algorithm is used for traversing or searching a tree or graph data structures. It starts at the tree root and explores the neighbor nodes first, before moving to the next level neighbors. Let's go over the pseudocode of the BFS algorithm. Let open be a priority queue of states need to be evaluated, and let close be a hash map of states that have already been evaluated. So, while open is not empty, we'll remove the best node from it. Let's call it n. Then add n to the close list, so we won't check it again. If n is our goal state, we'll return the backtrace path from the start state to n. If n isn't our goal state, we'll check all of its successors. For each successor s, if it is not in open nor close, we'll update that we came to s from n and add it to open. Otherwise, if the new path to s is better, means shorter than the previous one, if it's not in open, we'll add it to open. Otherwise, we'll update its priority in open. Another algorithm that is used for searching a tree or a graph data structure is the DFS algorithm. DFS stands for Depth First Search, and unlike the BFS algorithm, it starts at the root and explores as far as possible along each branch before backtracing. Let's go over the DFS pseudocode. Let S be a stack or some other data structure. First, select a node and add it to S. Then, while S is not empty, select a state V from it. If V is not discovered already, label it as discovered. Then, for all of these adjacent nodes, if they weren't visited, add them to the stack. Then pop the top node from the stack and follow those steps again and again until you reach the goal state. When reaching the goal state, return the backtrace. Okay, let's talk some design. In our project, we use the MVP architectural design pattern. The MVP initials stands for Model, View, and Presenter. In the project, we wanted to create a separation between the model that is in charge of all data calculations and the view that's responsible for all the input from the user and output to the user. The MVP obtained this separation using a middleman. That middleman is called the presenter. The presenter uses observer pattern in order to observe and command the view and the model. Let's say we want to generate a maze. First step will be to enter the required data, name of the maze, number of rows, etc. This action is carried out in the view. The view that is being watched by the presenter will notify that some change has occurred. Then the presenter will take the data and command the model what to do with it. When the model will finish all calculation and changes, it will notify the presenter again. The presenter then will take the data and command the view to display what's need to be displayed to the user. MVP design creates a complete separation between the view and the model. Next, let's see a demonstration of our Maze 3D project. Let's run the game. Okay, first, in order to generate the maze, we need to push the Generate Maze button. The tip tool tells us that. Now, we need to enter the name of the maze, the number of rows, calls, and levels. Then, press the Generate button. Now, in order to display the maze, we need to choose the maze that we just created from the drop box and press the Display Maze button. As you can see, the maze has been displayed. We can also play some music on or stop it whenever we want to. We can move with the character left, right, backward, forward, and also up and down between levels. We can also ask for a hint to help us solve the maze, and even ask the game to solve us the maze. If we want to change the properties, we can go to the File menu bar, select the Open Properties tab. Then we have two options. We can select the wanted Generate and Solve algorithms and press the Save Properties, or we can press the Load Properties button and load the properties from an existing XML file. We can also save our maze to a file and load it later using the Solve Maze and Load Maze buttons. If we would like to exit the game, we can press the Exit button on the main menu or the Exit button in the bar menu. We can also press the red X. All those ways will perform a safe exit, which will close all threads in the game. Thank you for listening to us. We hope you enjoyed this video and maybe even learned something. Goodbye.